clicked the button. Awesome. And I just officially started this recording. So this will be uploaded to the OSSF YouTube channel sometime later today.
Thanks, Dan.
Fabulous.
If you can you please all sign yourself into the meeting notes doc, which I'll link in the chat too if you don't have it open.
Thanks.
Cool. Alrighty, so I just moved up Konstantin. He had offered to give a presentation on Linux kernel developer identity stuff, and I took a very quick look at his slides, and there's some really good content in there. That might take up the majority of the time this meeting, but I think that's fine if we have a good discussion around it and learn a bit about that process. So, Konstantin, do you want to kick it off?
Sure, I'll be happy to. Just double check that everybody can hear me fine.
Yep.
Right?
You're slightly light.
Yep. Slightly light. Okay. I'll try to be slightly louder. Is that better?
A little.
I'm not. Yeah, hang on. I'll double check. I'm not used to this.
You might have a volume, a way to set your volume on your mic and bring that up a little.
Right. How about I do that while everybody else does something else? I don't want to hold up.
Yep. Well, I think we're all supposed to type our name in, so. So that'll give us a time to do that.
We have two different places where people are typing names. One of
Yeah, this happened last time.
Oh, sorry about that.
So we want to do it below, right?
Yes.
Yeah, under the date would be good.
All right.
We'll get all these protocol things figured out in time.
Seems like we should be able to build some fancy script to do it for us based on who's on the call, but I don't have that much time.
All right. So this is, hang on, I might have to rejoin because this is AirPods, and I think looks like I have to do it through the Apple weird mechanism, not something in the channel. So give me 1 minute.
Okay. Do we want to jump? Kay, how much time do you think you need to talk about collaboration with the CDF security SIG?
Very little.
Okay.
I think I'm just answering. I think there may have been some questions that came up last time, and so
yeah,
I'm just on point to provide an answer. Does anyone remember the exact question, so I make sure I'm giving an appropriate answer?
I cannot remember who asked, but my recollection was someone was just saying, "Hey, we have the CDF security SIG too. Is there? Are we going to converge them? Are we going to keep them separate? Are they going to have overlap? And how best to sort of manage the two different efforts?"
Yeah, so I found it in the notes. It was actually Andrew Martin, who looks like he's on the call again today, but he mentioned the CDF security SIG and some of the different SBOM working groups at the same time. And I said, we have the perfect person to answer questions about those. She's just not here today. So we'll see.
Okay, sure. So yeah, so the CDF security SIG, there are two things that are kind of happening there. So one is we're using that SIG for tracking information about the 3T SBOM specification. And the 3T SBOM, I can probably type in, thanks Kim for writing these things down for me. So there's I'm gonna help out in what, oh, sorry.
No worries.
Google Docs is great, but when you're trying to type the exact same place, it gets kind of quirky. Let me grab a link and then I'll drop it in here. Now back to oh. Sorry, as I'm fumbling around, I'm taking more time than it would take to explain to put a link in. So there's a working group, and I've dropped a link to it here. We're working on a software bill of materials standard. Some of the people in this call might be involved in that. There are a number of people from Microsoft. Anyway, so that group it's being run out of the OMG, but we're using resources from the CDF Security SIG. So we have a GitHub and Google Docs where some information is stored. So that's one thing that's happening in the CDF Security SIG. There was a separate thing that I got started earlier, which was an effort to talk about supply chain security, but that really hasn't taken off. And that aspect I would like to merge over and have that be in the open instead.
Very cool.
So does that answer the questions? I haven't done the work to merge it yet, but that's once we get agreement on how we want to deal with it here, then my thought is that I would go ahead and merge repositories and mailing lists and those things.
On that note, I just wanted to make sure, did we vote and decide on the scope broadening aspect of things?
I can give an update there. So did raise this on the is it the TOC or the TAC? It's too many foundations. The
This one is
TAC, yeah. Okay. And they said if we could outline the new scope for them, okay, then we would take it back and they would then review that.
Yeah, I
That
think it
was
was
the general
basically
gist.
the TAC. It's too early. Hasn't really thought through a process for this stuff yet. So
Yeah.
think through the scope we want, get ready, and then in a couple of weeks or a month or something like that, the TAC will have.
So what we
process in
should
place
do
to this.
is just put together a simple doc just to outline our scope, what would constitute secure supply chain, what would we focus on. So we could have the initial focus be developer identity still, that'd be the key area that we explore. But then we would sort of say we're also interested in, I don't know, attestations or bill of materials or capturing metadata and whatever else we're interested in doing as a group.
We might, I think it's worth us just, we've got another topic for today. So what I'm suggesting isn't for today's discussion, but I think in a future meeting, one thing I'd like to explore is maybe we do want a separate group that thinks about what our general story is for supply chain attestation and governance. And maybe we do want a separate group that just deals with it at an infrastructure level. So, here's what our plan is across the various teams, because developer identity is one aspect that we'll want to build on that infrastructure. But some of the other working groups, for example, the project metrics working group, I think would also want to build on top of that. I think I haven't spoken with them yet, so we have options to explore when we get back to looking at scope.
Yeah, sure.
Sounds good. All right. And that's later down the agenda. Constantine, are you ready to go?
Can you hear me any louder?
Yep.
Yeah.
Okay, excellent. So I will, that's a strike against the famed Apple works out of the box thing, right? So back to using Linux workstation for this. Let me present now. All right, so this is a case study. I'm not claiming that this is how it's supposed to be done. This is just kind of the way how we do it. And I will go into what's working, what's not working, and I will do a general overview of what it is. So first of all, before we go into this, you need to understand how the Linux kernel hierarchy works, right? Linux accepts pull requests from a small subset of subsystem maintainers. And this is a small subset. It's not, if you look at the maintainers file in a Linux kernel, you will see like thousands of entries in there, various people, but only about maybe 50 maximum people send pull requests directly to Linus Torvalds, right? Most of them, the vast majority of them, send just pull requests. They don't send patches, with extremely few exceptions. Andrew Morton does not use Git because it's too new, I guess. So he still sends patches and like quilt collections to him. He's the only one, as far as I know, that still does that. Everybody else sends pull requests, which can be PGP signed. The reason I mention this. So top tier maintainers who send requests to Linus, they themselves have sub-maintainers, or they may not have sub-maintainers. Usually they do. They would have like a subset of files, a subset of systems that they're responsible for. Somebody else will send pull requests or patches to them, and this is how they will be dealing. So this is like level 2 of the hierarchy. And then, you know, the depth of how many sub-maintainers that can there be goes, you know, it depends on the subsystem. It could be just 2 levels. It could be 3 levels. I don't think it goes very much deeper than level, 4 or 5. But it is really up to the subsystem. If you look at the maintainers file, there is every driver has a subsystem maintainer, and which explains why there's so many entries in there. So trust bubbles up. So like the maintainer who receives patches trusts or checks. It's up to them how they check the trust for every previous maintainer. And blame obviously bubbles down. So, you know, if Linus receives something from a sub-maintainer, Linus blames that person, and then the person will then spread the blame back down the hierarchy chain. So it's not a secret that Linux kernel uses PGP for its cryptographic attestation and developer identity. And the reason we're continuing, we're not planning to switch away from this. It's primarily because decentralized trust is a hard problem, and Linux development is a very decentralized effort. You know, there have been known efforts to combat any sort of attempt to centralize Linux development. It is still happening on multiple Git servers. It's still on multiple mailing lists. There is strong pushback against like, let's just move it to GitHub, or let's just move it to GitLab, or let's just use Gerrit or something like that. It's an ongoing conversation. There's a very strong-minded and willful subset of high-level maintainers who say, well, we'll never do this because Linux development must remain decentralized, so that no one entity can claim Linux development happens within our company, even if it's a nonprofit like the Linux Foundation. So Linux development does not happen to the Linux Foundation, just to clear up any misconceptions there. The Linux Foundation may be hiring Linus or Greg Hartman or a number of other developers, but and it can be managing kernel.org, but kernel.org has equal weight in terms of where Git repositories are stored. So there is no Linux kernel web of trust. We'll talk about the web of trust, but we must understand that there is no such thing as the Linux kernel web of trust. Each one of the maintainers has their own web of trust, like little fiefdoms of trust that happening. I mentioned that, you know, trust goes up and blame bubbles down, so it's up to each of the maintainers to maintain their own web of trust. And not many of them use actual web of trust in terms of the PGP definition of it. It means that, you know, if you sign this person's key, then, you know, and that person signs this person's key, then I can trust this person's key because it's got both of these signatures. Many of the developers do not care about this. They have a very direct relationship, which can be described as the trust on first use. I will talk about it in the next slide. And Linus Torvalds, for example, is one of those people. So, a few years ago, Linus said, if you're in my keyring, I trust your signature, right? It is not wrong. It sounds wrong when you think about it, like off the top of it, but it is not actually wrong. This is the trust and first use approach. This is SSH style identity trust. You know, first time you SSH to a system, it will say, do you trust this fingerprint? And if you say yes, you know, it will store it. And next time you connect to the system, if it's different for some reason, then something is weird. And it's the same idea with TOFU, right? The trust to first use PGP approach. And the first time you see somebody's key, you assume that this key is valid. And next time you receive anything signed from that email address, and the fingerprint or the key is different, then the PGP will say, well, something weird's going on. It marks both of the versions, all of the versions of the key as must be checked manually, and it would refuse to say this is valid or anything like that. So there are upsides and downsides to this. The upside is that Tofu scales better and is much easier to understand. You know, the PGP, Web of Trust, almost everybody misunderstands it. And even I've been dealing with this for the past 10 years extremely closely. Every now and again, it just still surprises me because I think something should be working and it actually doesn't. I have to go dig why this is not a trusted key, and usually it's because, you know, somebody's identity is it's been revoked, but you know, and it's just so complicated. So trust and first use.
Can I ask a question on that one real quick?
Yeah.
So somebody's identity is basically the tuple of their email address and their PGP key in this world?
Literally just their email address and the key that is associated with that email address that developer has in their keyring.
I also wanted to add that there's many ways to compute the Web of Trust that further complicates the situation.
Right.
I think even in the GNU-PG client, there's like 3 variants that you can use to.
Yeah, there's PGP Classic, then there's PGP, you know, with delegated trust. There's a way to say, you know, trust all the trust delegations of this person. You know, it's really hard. You know, I tried for so many years to sort of have, this is how you do it. And like I said, every now and again, I prove myself wrong, that this is actually not how you do it. It's got logic that defeats my understanding of it. So this is just to highlight that Tofu, trust and first use, is a valid approach to this, and a lot of developers are using what we call the direct trust relationship. You know, if I've gotten your key into my keyring, I believe that I had good reasons to put this in my keyring, otherwise, and so I have to trust it. You know, it would not just automatically show up in my keyring. You know, I must have had some sort of decision in the past to put it into my keyring, to import your key. And this is how Linus describes his workflow. And I've made sure that any sort of automatic fetching of keys is disabled for him. So we're cool there. So the downside, of course, is that it is easier to subvert Tofu than the Web of Trust, right? So the Web of Trust supposedly has a lot of precautions built in that it's not straightforward to just, you know, trick somebody into accepting a key, and you're trying to subvert the entire system. You know, if you know that somebody, for example, just joined Red Hat and it's going to be working with Linux kernel, you could send a fake patch to the mailing list saying, "Hi, I'm so and so at redhat.com. You know, here's my key," and so a lot of people will see it, and immediately with Tofu, PGP imports it automatically and saying, you know, I'm going to start trusting this from now on. This is not as terrible as it sounds, because, you know, the next time the actual developer sends it, there will be a different key, so PGP is going to say, "Whoa, something is weird." But this is like a way to disrupt the whole process. So, and maybe if the actual Red Hat developer never signs their any subsequent patches, then there's a way to kind of trick this and then send a patch. Anyway, so this is just, we're getting into potential abuses of this. And I also can think of many different ways of subverting the actual Web of Trust too. You know, if nobody's seen you before, you ask to sign your key, and you show, you know how it's done. You show your passport in a video camera. You know, it's impossible to tell if it's been just printed out 5 minutes ago or if it's actual document. So there's, I say it's easier to subvert than Web of Trust, but not as much as you think. So other cryptographic, yeah.
Sorry, quick question.
No, please go ahead.
Maybe I'm getting ahead of the whole presentation, but is there any way that, for example, WKD can come into play?
I will mention that in the future, yes.
Okay, cool.
Yeah. So let me first finish this. Other cryptographic platforms using Tofu is Signal, unless you do the actual verification of fingerprints, which is problematic, because usually when you talk to people about PGP, they say, "Ooh, PGP, no, you should be using Signal." You know, but this problem that we're trying to solve is not actually solved by Signal either. You know, Signal still uses trust and first use, and you still have to have other mechanism of verifying that you're talking to the real person with Signal, right? You have to either show the QR code mutually when you're person to person, or you have to call them or have a video conference and do the same thing. So this is just a different way of doing the same thing that everybody criticizes PGP is doing wrong. So Minisign and Signify are kind of newcomers to the field. If you don't know what Signify is, this is OpenBSD looked at PGP, said this is too hard, we're just going to do our own ECDSA elliptic curve signatures. They are very short, so you can actually just paste them on the website. And this is also like trust on first use, because the first time you have to get it from the website and put it in your storage somewhere, and then you can trust that it hasn't been changed. But there are other problems with that too. Let me get to that. So there is a kernel.org Web of Trust keyring. It's different from the Linux kernel keyring, which does not exist. The kernel.org Web of Trust, to get an account at kernel.org, we require that your key is signed by at least 2 other people who already have an account at kernel.org. So we publish the PGP keys that get a repository where all of the keys are stored. And so if you're a new person who is just coming in, who is going to be a maintainer, and you want an account at kernel.org, you can actually import all of those keys. And so you're delegating trust to me. I'm become your the trusted introducer, if we're talking in the certification authority lingo here. So this is delegated trust scenario. You can trace each key to Linus Torvalds. So you can sort of trust that I'm doing the right thing, but you don't have to. You can always verify. You can look through each keys. You can trace the signature to Linus Torvalds. And I doubt anybody actually does this, because I've been doing this for a while. But if you wanted to, I provide all the mechanisms to do this. So it's not blind trust into me. Anybody can verify it. And then we publish key graphs. So this is done in SVG, and it's a little tool that I wrote specifically for this purpose. So you can see where it is done. I hope I can. Wait, you probably can't see this. Can you see this?
No.
No.
Maybe taking it a little bit too.
No, it's fine. No, it's fine. Just if you just load,
slides.
load the slide deck. I believe it's been shared in the attachments, and you can click those pretty graphs. So
Cool. I also pasted one that's probably similar for the Arch Linux on the chat, if you're curious to see that one as well.
oh, yeah, cool. Right. We should copy this and see if you want to take a look at that. I'll.
I copied that, by the way, into our meeting notes, because
Okay, good.
I believe these chats all disappear when we hang up.
All right.
Thank you.
All right. Yes. Let me go ahead. The honorable mentions, the key servers. Why are we not using key servers? Key servers are a bit of a rotting mess, because they've been written by, everybody uses the same implementation that was written by a PhD student as their PhD thesis back in early 2000s. And it was written in ELISP that nobody really understands. And it was an actual PhD thesis, so nobody understands how it actually works. And the person who's written this does not care really to continue maintaining it. There was a significant problem just about a year ago when you could basically denial a service at your PGP client by creating a holy mess of signatures on the key. It's been fixed in PGP, but this is we're considering key servers as really untenable. They're all the replicating ones, self-replicating ones. The GNU PG still uses. And it's also, the design is GDPR non-compliant. There's no way, if somebody says, remove my data from this key server, it's already been replicated everywhere. And the way it was written is to never allow any sort of removals. So when GDPR first showed up, a whole bunch of key servers in Europe just went offline, and there was a big disruption. There's a web key directory, which already got mentioned. The trouble I have with that is that a web key directory delegates trust to server administrators, so like me, without any way to verify anything. The way it is designed, it strips third-party signatures. So when you're downloading a key from the web key directory, this is it. You trust that it hasn't been tampered with by the administrator, such as me, or any shady government entity that can capture the traffic and rewrite the TLS. So I'm kind of trusting those two not to happen. Which is why I don't really like it, because there's no mechanism to trust but verify. You can trust, but there's no way to verify it. All right. So the trouble that I have, the biggest trouble that I have is that, yes, we have this all set up. But, how do we educate kernel maintainers that this is available and they should be using this? So there's a maintainer's PGP guide document, that's kernel documentation, that it covers the topics like, why do you want to use PGP? How do you properly secure your PGP key? Where to get other people's PGP keys? How to check if the keys are valid or not? How to find an imposter if you could? What and when to sign, which we'll get into the next slide. And the Linux Foundation sponsors PGP hardware tokens for maintainers. So that if we had an agreement with NitroKey, saying that they have a kernel.nitrokey.com, I believe, which is the a shop front end where the developers can go if they have a kernel.org email address, or if their email address shows up in the maintainers file, they get a free NitroKey start so that they can put their signature and encryption keys onto the hardware token and remove from their workstations. It's not used.
What does the exchange look like for the hardware tokens? Like, do they have to show up in person?
No, it's shipped. So you trust that this German outfit that produces these does not, do anything nefarious. Which, you always have to trust this with hardware tokens, right?
It's also
So this is similar
open
to a
article correctly, so you should be able to, if you really wanted to, make your own from like a 3D printer and a PCB.
Yeah. So go ahead.
Is it just an alternative to YubiKey then?
Yes.
Basically,
Yes.
Okay. All right.
So YubiKeys are proprietary hardware, proprietary software. Everything about it is proprietary. The NitroKey Start is actually a GNU free hardware, like open hardware chip that was actually developed by FSF Japan, I believe. And so that we chose specifically because all the software on it is open source and all the hardware all the specs are available. If you trust that NitroKey is doing the right job with it, of course. We always trust the manufacturer. There's no way you can get out of this. Okay. So what gets PGP signed, right? So the kernel release tarballs, when you go to download the kernel release, you go to kernel.org and you click on the latest release, you download the tar.xz file, and you can download the detached signature to it. And that detached signature is actually in the Git note attached to the actual tag, the Git tag. There's a little wrapper script that Greg Kroah-Hartman runs that will generate detached signatures and put them into Git itself. So the upside of this is that if you mirror clone the stable Git tree, you will get all of the tarball signatures and all of the tag signatures and all that stuff. So mainline and stable Git tags are also PGP signed. This is a native functionality to Git. When you create a Git tag, you can say -S or -lowercase s, and this will add cryptographic signature to the Git tag. And it can be verified using Git native command.
So these are all signed by Greg or someone else that does the release?
These are all signed by Greg because he's currently the person who is cutting all the releases. And also the mainline Git tags are signed by Linus Torvalds. All the tarballs are signed by Greg Kroah-Hartman because he's the person who's doing all the stable tarball releases. Does that make sense?
Yeah, thanks.
Okay. So pull requests sent to Linus. If there are a tag, usually what people send, please pull this URL and that will contain a tag. Most of them contain signatures on the PGP, on the Git tags themselves. He only checks signatures on repositories not hosted on kernel.org. He's wrong. I've talked to him many times saying you should not be trusting me. Trust the developers. Do not trust the infra. He is winning this argument because unfortunately, yes, he's wrong. I will put it out there, and he knows I think that he's wrong. He doesn't care. He says, there is enough trust and checks and balances, and I trust you. And I said, okay, fine, but you're wrong.
On the upside, we've come a long way since he was against signing altogether. So
yes, he's still against signing. He's still against signing commits. We don't enforce signing of commits, which is kind of makes sense. So if you look at this link here, on peoplekernel.org, I discuss what actually goes into a PGP signature and a commit. So when you have a PGP signature on a commit, that proves that everything below that, in the history is automatically bit for bit verified. So the reason he's against Git commit signatures is because only the tip needs to be signed. Unfortunately, there is really no way to just sign the tip, right? Tip can only be a tip for like 2 seconds, then it will be something else.
And I think that's exactly the problem, that there's a window of compromise to some extent.
Right.
Yes. I also don't know if it's worthwhile mentioning push certificates and such, because I think that's the next level of problems when it comes to Git metadata.
Right.
Signing.
Yeah, I wouldn't touch in this conversation the push certificates because it's esoteric knowledge that most people will not probably find very useful here. But I'm in agreement with you. We're actually going to start publishing sort of an audit feed of all of the pushes to all the repositories as a public inbox, so that you can go back and then we'll start publishing the push certificates as part of that. But we're not requiring or checking them. It's just going to be sort of an audit trail. All right, and so there's in addition to that, there's a experimental way to sign patches. So that patches are not part of a Git tree, obviously. So you send them to a mailing list, and the problem exists that nobody actually signs them. So and mailing lists are sort of untrusted by their nature. So there is a way to do it now. It's an experimental feature. Extremely few people use it. I'd like to convince more people to start using it. It actually does not modify the patch. It's a detached signature sent to a different mailing list. And it's sort of a collection of hashes that verifies the metadata of the patch, sort of like who it's from, what's the subject of it, also the message on the commit, and the actual the code that is in the commit. And the tool that I wrote for this is called B4. This is for working with patches sent to mailing lists, and it will verify if this data is available. It will give a nice check mark saying it verifies in the client. It doesn't trust any externals. It still uses PGP, obviously, for this. All right, any questions about this slide?
I wanted to add another question. Sorry for asking so much. I remember a couple of months ago there was a conversation about having patches be signed and somehow be able to embed that signature inside of the Git commit.
Right.
I think there was a couple of question marks raised there, but I think it's also a very interesting feature. Do you know if that's going anywhere? Do you think that would be desirable in the sense of B4 being natively supported? And
I'm not sure. Yeah, I'm not sure about natively supporting it. The trouble with this strategy has been pointed out to me by multiple maintainers, saying that, well, if we preserve the signature, unfortunately, when a series is sent to a maintainer will almost always modify it in one way or the other. Like they will add sign-off buys, they can change subject, they can change minute things about the structure of the actual code. They may remove spurious semicolons or new lines or anything like that. So what if we embed this in the Git commit, if we use a Git native, if you like, way of preserving these signatures, then they will almost always be invalid because there's no way to say, please preserve this. The maintainers will have to not make any of those changes, and the maintainer's life actually will become harder because they would have to say, oh, you have a new line here, please resubmit. And this will be too much back and forth. It is much quicker and easier for maintainers just to say, well, I'm just going to make this edit right now. And since it does not change the logic of the code, then the sign-off still stands. So that's where discussions have led, and the reason I haven't really investigated any further is because most of the maintainers for the Linux kernel, at least specifically, said that this is not a useful feature for them to have anything like that, because they almost always modify the patches, either the code or always modify the metadata of the commit, because the date will be different, and the sign-off buys or the taglines will be different. So that's where it kind of ends. But I don't think it's a useful feature. I don't think it's very useful to work towards that end. That's my view on this.
Thank you.
Mm-hmm. All right, we're coming up to the end. So is this whole setup working? Right? I've described this. So it is up to each maintainer to enforce cryptographic attestation. We're not enforcing this. I mean, Linus enforces this for pull requests received from outside of kernel.org. Right? He does not enforce it any further, and I can't convince him because I can't just say no. I'm sorry, but I'm gonna overrule you anyway. Sub-maintainers, as far as I know, some of them require that the tags are signed, or some of them are. I think one of them is requiring the patches is assigned using the attestation mechanism that I suggested, but it is very, very small subset of code that's being processed and received. And I can attempt to gather data on how widely it is used, like the entire cryptographic attestation of pull requests, for example. I expect the results will be extremely disappointing, which is why I haven't yet done it, because it will just sort of wet my blanket, so I don't want to do it. I want to pretend that this is actually going somewhere. And to point out, a lot of maintainers actually actively push back against sort of this cryptographic attestation of code they receive. And their argument is valid. They say, we must assume that attackers have state-level budgets, are able to coerce people or steal PGP keys, right? So the they can go and steal PGP key from a hardware device or from a laptop, or just coerce a developer, threaten their family, give them big bribes. So if we place too much trust into cryptographic signatures, then we are going down the wrong path. All the code several maintainers told me, all the code has been taken at face value and assumed to be malicious. So regardless of any prior contributions by the developer or any kind of signatures or anything on it, they said, we want to always treat the code as it was sneaked in by a malicious party. Obviously, this doesn't scale all the way up, right? So Linus cannot possibly go through the entire code, which is why he does rely on cryptographic signatures from top-level maintainers.
Yeah, so that's actually what I was going to bring up. So my name's Gavin Heineman. I'm from Intel. I've been working at open source for about 20 years. I used to run the Safety Critical Linux project at Intel. This trust web exists in the kernel, but that's not really where the trust lies, right? The trust lies in the review process.
Right.
Most maintainers, the code they're committing didn't come from them for the most part. So this is sort of the final firewall. It's not the primary trust mechanism.
Right. So which one is harder to do, right, for an attacker? Is it harder to steal their cryptographic stuff, or is it harder to sneak in a code that people are just going to miss? Because C is fairly easy to obfuscate. Right? So you miss a semicolon there, and suddenly the entire logic is different, or different fall through. Right? That they're trying to address this in the code itself, but it's a valid observation by maintainers, which is why a lot of them are not specifically using cryptographic station, because they don't want to have this crutch that they're relying upon that could be a false sense of security.
Yeah, and this is ultimately where we came to on the safety project, which is we could never rely on the goodwill of the people submitting the code. It didn't need to matter where it came from. We could only ever rely on the expertise and the diligence of the maintainers.
In one hand, it did happen before that somebody just removed the equal sign and suddenly there was a backdoor in the kernel, right?
Well, this was on a CVS export like many years ago, right? So this is not anything that is weird. Yeah, as far as we know, nobody used it. Everybody was aware of this when it was, because nobody really used that at CVS. Yeah. Anyway, so yes, valid point. Not as horrible as it sounds. Yes.
No. The point that I'm trying to make is, and you said it. It's easy to obfuscate C code to make it look benign, but it can be malicious. I think the broader point then is that we need both. We probably need to minimize impact of a merge that was not properly reviewed. Like another anecdote is Heartbleed was merged on New Year's Eve of 2012 or something like that, where everybody was either hangover or really wanted to go out to celebrate. There can be situations like this, and I think putting handrails or guardrails everywhere is something we should strive for.
Right. Yeah, I agree. Well, when people bring up this argument that we shouldn't be trusting PGP, I say, well, there's nothing preventing you from doing both, right? To have a sort of initial level of check, this is actually failing signature or this is actually passive signatures. Give it no level of trust, but just sort of a way to cut off the lazy attacker, right? You haven't even done your homework, so I'm not even going to pay attention to you. But then you review the code. This makes your life easier. This is at least my counter argument to this. I'm not sure I'm winning that because a lot of them are very set in their ways, but at least I agree with you on that argument.
On a related note, I just dropped a link into the chat. I just yesterday was made aware of a hackathon that where someone was working on some artificial intelligence to see if the code that someone commits recently matches other commits by that person in the past. So that's a way to see if it gets at the nation state or someone stealing a GPG key or something. So,
sure.
So like just stylometric checker for patches.
Yeah.
Interesting.
Yeah, we should be aiming to make the life of attacker more complicated, right? Have more checks, have more things they have to defeat instead of just being as lazy as just sending a fake from to a mailing list, and then just defeat this by volume instead of effort. Right, so Git tags and tarball signatures are checked. There was a couple of times when the backend process didn't do the right thing and the tarball didn't match the signatures. Immediately, GRSec people may now need to mock that something has gone wrong. So that's how they operate.
Hey, Constantine, I probably should have asked you earlier, but is there a URL for the slide deck so we could link to it later?
Yeah, sure. I believe it's already an attachment, but I'll paste the actual URL of the presentation. It's open to anybody with a link, so you can be able to get to it.
Fabulous. Thank you.
Yeah. I think that's it. Yeah. So Q&A, is PGP quantum proof? No, and neither Bitcoins, you fools. That's my usual answer. Anything else anybody wants to ask? I think I went over what I thought I was going to go over, even though I already cut a whole bunch of slides about PGP out.
I think if you choose the right hash and the right signature scheme,
What you want is a 256, a much longer hash, because your number of bits get halved.
I see that we're coming to SHA-256 soon on Git. That's good news.
Yes,
I see
right.
movement all the time.
If you look, I think there's a link I provided to peoplekernel.org with sort of my. Let's see where it is. All right, you'll find it. So I talk about when we sign the tags, what about the SHA-1 signatures or SHA-1 hashes that right there that the Git uses, and it is actually not, as far as we know, it's not yet possible to have an attack that's done on SHA-1 and have it succeed in Git because of the precautions that Git already put in place. There's a SHA-1 collision detection, for example, that is in Git code. And it's just not as easy to do it in Git as supposedly like to padding a PDF file. This is harder than you think. But yes, there is work in Git to move away from SHA-1. Unfortunately, when Git was written, this was kind of assumed that this was going to be forever, and which was a wrong assumption in the first place. But this means that changing it would require sort of a flag date for repository, or have basically two repositories existing in the same at the same time, where every one set of commits is using SHA-1 hashes, while the other one is using SHA-256 or any other hashing mechanism that you choose. It's hard. It's a hard problem.
Yeah, I also made an analysis back when everything came out, and with the code churn happening on the Linux kernel, by the time you collide a file or like a commit, it will be or a blob to be exact. It will likely be replaced by a new one. So that you're back to zero. You won't be able to replace it. I have some graphs around if anybody's interested in that. I think for most of the popular repositories, I found that you can just collide a README file or a license, which it's an interesting academic attack, but nothing really scary just yet.
Right. If we go back to the topic sort of identities, and I mean, I can talk about Git and SHA and PGP like a lot, and you'll be asking me to shut up. But if you go back to sort of the developer identity, any other questions about that specifically?
I did. You mentioned there's a URL. Can you post that, or where is that?
Yeah, hang on. I'll do it. Let me stop presenting this.
The only other question I have is, have you caught anybody trying to make attacks this way? Has any of the work you've done actually been in use that you've seen?
I have no. I mean, I don't check. How would I check? How would I know that I got somebody or not? Right.
I mean, if somebody forged an email address and sent something with an invalid signature or something like that.
Yeah, it would be up to the maintainer to catch it. I don't have a mechanism of checking this.
Yeah. But you're not aware of anything like this? I guess prevention is the best. If people don't even try it because they see all of this in place. That's also.
I guess, yeah. Make it scary to even try, right? Make it. Well, they will probably almost certainly catch it. That's how I at least try to do it. So I see that somebody pasted sort of the Hagrid server. It also strips third-party signatures, which is not acceptable for us. You still kind of basically trust the administrators of that server that they're not doing anything malicious. We're trying not to delegate trust to infrastructure. This is like the whole, ever since the 2011 kernel.org break-in, the mantra for me at least, saying, do not trust infra, do not have trust is in developers, never in infrastructure. So anytime there's a solution that says, oh, here's a way to do it, but you have to trust the server to be uncompromisable, then it is not an acceptable solution for us.
How do you handle key rotation? Have you had to deal with that?
So key rotation or like expiration extensions, with the PGP, the way I say it, if you added a new key or if you extended the expiration date or added a new subkey, you send there's documentation saying how to do it. They just send an email to the mailing list with the key export, and then I process it, and then I make my judgment. If it's a expiration day extension or a new subkey, then it's easy. You just import it, and then the old PGP magic makes sure nothing malicious is happening. If it's a new key, then I at least ask to sign with the old one, and then this is how it's usually done. If the old one's lost, then you have, but you have to go and sign it by at least 2 other people with accounts at kernel network already.
And I wanted to add that there's a explicit revocation mechanism on RFC 4880, and as far as I'm aware, GNU-PG eats it and manages it well. So I don't know many people have that set up revocation keys though.
Yeah, I haven't, in my 10-year experience doing this, I haven't seen a single revocation. People just stop using the key, which is not what you're supposed to do, but almost nobody preserves the revocation certificates that PGP creates on key generation.
Yeah, I think the only other thing I would bring up is that the method of having your key authenticated by 2 people with keys already is sort of based on the idea that people see each other at conferences, given the worldwide distribution.
With pandemic, we kind of relaxed that rule, saying you can do the video call. And I always stress that we're not trying to verify your government issued identity, right? We just want to say this person is working with this maintainer, and this maintainer knows them as Joe Doe, right? And then you are signing this as verifying that, yeah, I believe this person is Joe Doe, because when I talk to them, the information got back confirmed to me that the Harry Potter idea of what was in my tank when you saw me 2 years ago, or when you entered my room. It's kind of same idea. Sort of make sure that this person is who they say they are without relying too much on government issued identity documents.
Thanks for that presentation. I found it really useful.
Yeah, thank you. Go ahead, Tay.
If you could do it in an ideal world, and I know there are limitations to what can happen in the Linux kernel community, but if you were making recommendations for new projects, or if this group was coming up with a common infrastructure that others could use, what would that entail? It might be too much to think of in just these few minutes, but.
No, this is an extremely good question. If there's a new project coming on board, how do I say this is how you would do it? I always recommend, this is how we do it. If you have a project, if a project is on GitHub, it's already centralized, you sort of can use that as your centralized mechanism of distributing trust. You can have everybody submit their public key to the GitHub. There's a way to do this, and then you can use the verification this way. Sort of use GitHub as your key server, basically. You can get people's keys from there. Unfortunately, everybody has a misunderstanding of why PGP is terrible. PGP is terrible not because of a problem with PGP itself. It's terrible because delegated trust is terrible. This is a hard problem to solve. There is no easy and simple solutions to this, and everybody just think this is a problem with PGP, but it is a problem with any mechanism of delegated trust. You either have a central authority that you delegate this all to, like the CAs with TLS World, or DNSSEC with the DNS sort of part. These are 2 major ones. Or you have to jump through hoops that everybody misunderstands, and everybody says, wow, this is so hard. Why does this suck so much? But it does not. It's not a problem with tools. It's a problem with being hard itself.
I will add that the GPG CLI is a little confusing, and that there's no blessed library for it. I mean,
It's
the
true.
GPGME is just basically the open wrapper.
But it is also getting better with the GPG 2.2. There's a lot of things that are less terrible than they used to be, and this is improving continuously. It's just a project that needs some serious funding.
Right.
Yeah.
That's a very important point.
Right.
So we only have like 9 minutes left. I'll just cover up some last things, I guess. I found this presentation really helpful again. I just want to mention, I added a list at the top of ideas for future presentations. If anybody wants to hear a similar topic from another project, and maybe you have a point of contact we can reach out to, add that up there and we'll go ahead and try to schedule them. I think these are really useful. Somebody from the Chromium team at Google mentioned that they'd be up for doing something like this on how they manage Chromium, which is a different kind of open source project. Yes. So yeah, type stuff up there if you're interested or have ideas. We did case follow-up already from the agenda. The next thing I just want to call out is that threat models doc that we started last time. There's still some good stuff being added in here. So take another look and I'll send out another reminder after this to add other things and review what's been added. I think the next step, once things slow down and people stop adding new ones, is for us to review and kind of categorize and prioritize and figure out which ones we think we can actually improve and make progress on in this working group. A bunch of people added links to other kind of collections of threats, so I tried to merge some of those in that we didn't already have. Like Santiago has a big list of them in a CNCF security repo of actual attacks that happened. So I just wanted to call that one out. Anything else anybody else wanted to cover today? Before we run out of time.
Has anyone looked at how this effort we're doing in this group maps to the work that was done in the security threats group, the document that Michael, what's his last name?
Scovetta.
Wrote? Yeah. So is there overlap between these?
Yeah, so David and I attended that meeting this week and read that doc. His doc covers a couple of these topics as well as a ton more. So I merged the threats from his doc in here. I think the difference is we're not trying to actually come up with and publish a list of all these threats. We're just trying to catalog the ones that we want to tackle. His doc was kind of identifying threats across all of, like a whole bunch of different threats across open source projects just to make people aware.
Okay. So the scope here is more on supply chain security then?
Right. And,
okay.
Yeah. There were a couple other things like that that we found, lists of these. David had a bunch in his course too that I reviewed and merged in. Kim, did you have anything else? I don't think there's much else on the agenda.
No, I think you covered it. I think we can save the scope discussion for next time, or maybe just split up into a small subgroup and work on that doc for the TAC together. Seems like a good plan to me for those interested. Yeah, that's it from my side.
Is the lead for this working group Dan, or I don't or Kim, or my apologies if I don't know. I'm still trying to figure out who's who here.
Yeah, I mean, we have a facilitator section at the top right now, which is Dan and I just tag teaming. For people that are also interested in facilitating meetings, that's great. We want to be leads, open to everyone. David, I think you're volunteering, so feel free to add your name at the top up there.
Were you volunteering? I wasn't there.
I'll have to think about that.
You know where to add your name if you decide.
Yeah, I think, I'm not sure. I think, we're just getting off the ground now. So once we get through sort of that threat document and figure out what we're going to tackle first, and, I think the meetings might change slightly to be more, about actual work that's being done as opposed to trying to learn how scary the world is. Cool.
All right, I'll upload this to YouTube once we get the recording and everything. Thanks, everyone.
Awesome. Thanks again, Constantine.
My pleasure.
Thank you.
Bye.
Bye.
Thanks.
Thank you. Bye-bye.